Welcome to the lecture series of DBMS, AKT course curriculum, subject code PCS 50. Today, we are going to discuss about the key important points of the transaction unit, that is asset properties and the concurrency control. I, Ritin Bahel, welcome you all from the ABES Union College, Ghaziabad, to the lecture series of DBMS. Today, we are going to discuss about the very important key concept of the transaction unit, that is asset properties. Now, what do you refer by the asset properties? And why it is so common and more efficiently used? If you see that in the last unit topic, we have covered about what's the transactions, and we have talked about the two things, that is transaction is the smallest logical unit of the work, and we perform two units of the work, that is read and write operations. Now, in many kind of the companies or a Viva question, you can be asked what is an asset properties and what is this. The second or third question from the DBMS interview question, they will be asking what are the asset properties? What do you mean by the single thing? So let us get into the picture and detail part of the asset properties. Now, the asset properties has been divided into the four subparts. That is by the capital names of the first capital name of this thing, that is your asset. So the A stands for the atomicity, the C stands for the consistency, the I stands for the isolation, and the D stands for the durability. Now, each have a separate meaning. Now, if you see that, it looks like the overall transactions is depending upon these properties. And these properties enables all the transaction that is happening in today's real world looks so easy. What are these properties and what is the importance of these properties in the transaction? Now, asset is a concept and acronym that refers to the four properties of the transaction in a database system. So basically what you can refer is these are the properties of a transactions. Okay. These properties ensure the accuracy and the integrity of the data in the database. That is one of the most important points. Because what is the concern of the database? For example, you have X thing or a Y price, something like this. And you have 2x, then it would be 2y, and so on. So what important point is, whenever I change something, it should be reflected back properly. Or whenever I want to retrieve it back, it should be the same data. So database consistency is the key point for our transaction and the concurrency control. Okay. So my major goal for this point is my database consistency. Now, what do you mean by the consistency? Is whatever the data is earlier in the database, it should reflect the same point. And whenever we have the same thing, we run a query for that, we should get the final result at the same point. So let us go into the real part of each property and try to understand them. Now, in terms of DBMS, now atomicity by single unit. Now, by atomicity, now if you see that what is atomicity, if you break this word, that is an atom. So what do you think is this? A single unit. Okay. So whenever I talk about a single thing, what does it mean? In terms of DBMS, atomicity refers to either the execution of the transaction got completed and committed. Now we have seen in the last transaction state, it is begin, partially completed, and completed. When it is completed, the database changes whatever has been done from the local memory of the buffer part should be reflected back to the disk part. Okay. Or no transaction at all means transaction is aborted. So what does it mean? Either transaction will start and it will work to the commit phase, or if it fails, it will go to the abort. So what does mean? Transaction will happen or it will not happen. Simply, there is no in between in this thing, and that is a property of atomicity. A transaction must be an atomic unit of the work. Okay, which means that all the modified data are performed or none of them will be. So whatever is an item is, or let us take an example, we have A and B, A have 50, B has 10, we transferring 40 to here. So this become 50, this become 40. Okay, if this happens. And if this fails, it will be A will be 50 and B will be 10 only. If it fails. This means is Either we are going into the complete part, that is commit, or we are not going back and we are getting it to the fail, that is abort, and we're getting the same values for A and B. So in the first case, A value become 40 and B value become 50. In the second case, A become 50 and remain same, and B become the same. Now let us get into the more detailed part. Now getting the better example for this thing. The transaction should be executed completely or it fail. So let us take an example for this thing. For example, let a parent account A has a 70,000 in his account. Okay. So similarly, we have saying a 50, we have 50,000, so that's 70,000, from which he needs to send 50,000 to the university account B. Mainly, generally, it happens whenever the students have to pay their fees in the month of July or other something. So the semester starts. So the parents have to send the money. So we have taken this kind of a scenario. So just take an example of student A's parent have a 70,000, which he needs to send to the 50,000 to the university account. Now in account of a B, a sum of 10,000, 1 lakh is already present. Okay, because somebody hasn't done it, doesn't make any difference. When 50,000 is transferred to the account B, the sum will become 150. Okay, this happens. So what we say is that during the transaction, suppose the first operation debits executed successfully. What it means is from the account A, we are able to deduct the money, but the credit operation fails. Okay, so what the credit operation will, it is in the picture part is parents accounts. Now we have 70,000 in the beginning, 50,000 has been debited, remaining amount is 20,000. Whereas in the before 20,000, it got failed, so it's here. Now what exactly is this thing going on? From the parents' accounts, 50,000 has to be debited and to be credited into the college account, but it has failed. Now, who is responsible to getting the 50,000? Because college will claim, I have not received the money. The parents will say, I have sent the money. So, intermediate transaction would not happen. So, what it happens? This got fails, it got rejected, and this money is credited back to their account, the parents' account. So then again, the system has, the parents' account has a money of 50,000 plus 20,000, that is 70,000. And B has, the college account has a 1 lakh rupees in their account. Okay. So that's why the transaction is completed or it is not. There is no intermediate, because you can see from this scenario, it's very difficult to say that 50,000, where is this 50,000 and who is responsible for this 50,000? Okay. It means that if it is completely executed, it is completely executed from the beginning to the end without interference from the other transaction. It is like the data from the one consistent state to the another. Okay. So what we basically have is we should have a complete transaction. Let us an example for account A and account B have rupees 10,000, 1 lakh, and 70,000 respectively. So the total amount of 1 lakh plus 70,000 is 1 lakh 70,000 before the transactions. Okay, so we can see that the account has a 1 lakh, B has around 70,000. So before the transaction, nothing transaction hasn't happened. Okay, we have not credited any amount, we have not debited any amount. So what is going to happen is when any transaction is executed, then the total amount again should also be 1 lakh 70,000. Earlier also in the same example, 70,000 was there in the parents account, 1 lakh was in the college account. If it happens, the earlier sum and the later sum is what is 70,000? That is the definition of the consistent. So what it says is A and B has 100 and 50. Let us take a small example. So earlier sum is what? 150 of A plus B. Now A is transferring 30 to B. So what A become? A becomes 70 and B become 80. Now if you add these two, what is the sum? 150. So if you see that before transaction, this is after transaction and this is before transaction, this is 150. What it means that if it is completely considered from the beginning to the end without the interference from the other transactions, it should take the database from one consistent state to the another state. Means whatever the sum value is earlier in the transactions, whatever the value of the state is, it should be done the same thing after the transaction. So, in isolation, this is one of the most important properties that help us to achieve concurrent execution of the multiple transactions that is happening. Now, when an isolation says this, now if you see the word with isolation, what do you mean when isolate is something isolated? It is something separate. What is an idea behind this property is now if you see this in most digitalized world and everything, we are going for a multiple transactions. Let us take a very common example. You have a bank server for a college, and different students or different parents account students are debiting their amount to the college fees. At the same time, to the same server, different transactions had happened. Now, what is an ideal solution for that? The ideal solution for that is an isolation. So, what does it mean? Is if a person who's sending from Delhi, he or she doesn't have any effect that at the same time on the same server, someone else is sending from the Karnataka side. So that let's see an example. This property tell us that a transaction should appear as though it is being executed in isolation from the other transaction, isolated. It means there is nothing else. Even though many transactions are executed correctly, that's what I'm trying to say. It doesn't make any difference. Okay. So let us take an example. You have a server here. Okay. T1 is happening from city 1, X Limited. T2 is happening from the city Y. T3 is happening from the city Z. Okay. They all are occurring at the same time. So T1 doesn't know T2 and T3 exist. T2 doesn't know T1 and T3 exist. And T3 doesn't know T1 and T2 exist. So that is the property of isolation. This means that if more than one transaction is taking place in parallel, then the occurrence of one transaction will not affect the other transaction. How we achieve that? We'll see that with the view serializability and the conflict serializability. If any transaction is using data item, then it cannot be used by the other transaction until the first transaction ends. That is the important one. And this creates some problem also, like starvation, deadlock. And so, these are the things that in that we're going to cover these topics. Okay. So isolate means if a transaction is happening, it doesn't have any effect on this thing. And if it is using some data item, it should be free from the, it would be free only if the other transactions wants when the transaction ends. Okay. Let us take an example. Suppose we have two transactions, T1 and T2, which are defined as follows. Okay. Now let us see what are transactions happening. Read A, we're performing read, then A minus 5 lakhs, 50,000, then write A, then read B, this and this. Okay. Now, if you see this thing in between this time, this is a timeline. Okay, now this is something that's timeline happening. So the first transaction that is happening is read of A. So from the memory, it goes to the buffer part and they have taken the value. And whatever the value of A is, whatever the value is, T1, 70,000. In a transaction T1, a parent is transferring from an amount 50,000 from an account to the university account B. The initial balance of account A is 70,000. Okay. So what is happening is 70,000 ke baad, so what we are left with after 50,000 is 20,000. Now transaction T2, the bank is adding the interest of 10% in an account A. Okay. So read A into 1.1% and write it. Read A will give the wrong value. Why? Because till now, for example, A here is 70,000 and A here is 20,000. It intermediate this transaction. So this rate of interest will be opening on 20,000 into 0.1, whereas it should be 70,000. Okay, so that is a problem. So transaction T2 starts after the addition of the data item A, but before the write of it. Okay, so that is a problem. So even the correct value should be something else, but we are getting some wrong result. Okay, na? So A is there, we have not write it down, so it will take 70,000, but exactly the value should be 20,000 and so on. So it will create a problem. So that is why isolation is an important property and it helps you out to get in the picture. The last property, that is asset property, is the durability. But it is a very durable, when it means it's strong, it's be able to save the data. So that is the property says is if anything happens to the server side, there is a natural calamity or anything. Whenever the data has been updated from the local memory or a buffer to the local disk or the DBMS, it would not be changed after that. Again, we have to repeat the transaction or we have to do it again. Once the changes has been done, it will be saved automatically for a longer time. Right? Durability ensures that changes made to the database wire transaction that are successfully committed will survive permanently even the face of the system failure. System failures can be fire, you can have natural calamity, and many other things. Okay. This is so the data within the database will not be services outages, crashes, or other cause of the failures. This can cover up with any kind of. So whenever the transactions have been completed, whatever the data has been changed would be updated in the database and it will survive from these key points. So service outages, there are fire outrage, there's a natural calamity, it's a system down, maintenance is there, and whatever it is. Once it has been updated, after the transaction is committed. So what is the point is transactions should commit and then only it would be reflected. Okay. So these are the properties of the asset properties. So atomicity, consistency, isolation, and the durability. Okay. Another important point is the concept of the concurrency. Now, if you see that most of the transactions is happening again and again, but what is the important point going to happen? What we have seen in the isolation part. Now, the database system can be classified according to the number of users we can use the system concurrently. For example, a DBMS is a single user. If that one more user can use the system, and it is a multi-user if many users can use the system simultaneously. Now, most of the times it is a multi-user also. So, let us take an example. For example, an airline reservation system is used by 100 the travel agent and reservation and concurrently. How this thing happens? Now we see that we need to perform the isolation. We need to get the data in the consistent state. So how do we get this thing? So one of the best method is one by one. Let us go to the bank example. And when we see that there is one teller only and there is a queue, what is going to happen? One teller will solve one problem to the client, then it will move to the next client and so on. Now, what is the problem with this system? Time. How much time is there? The resources wastage. Now, if you see this thing, one of the most important critical time in this today's world is time. So this will reduce the performance, this will reduce the efficiency. So how do we cover up these points? Let us talk about these things. Let us take an example. I've already seen it. When a multiple transaction are trying to execute simultaneously, then can be two possible ways. Serial the sequence execution. I have taken an example of the bank teller. You have one person, he will solve the teller, solve the problem with the client. Once it is done, it will do the next client and so on and so on. But it has a problem, waiting time and so on. Non-serial or the concurrent execution transaction, multiple is happening. Now how? So let us take an example. There are two students S1 and S2 who are submitting their fees to the college at the same time. We have taken this example using the web or the mobile application. Okay. Now S1 is submitting rupees 2,000 in the college amount and S2 submitting rupees 3,000 in the college. Both the transaction T1 are executed at the same time means they are executing simultaneously in a serial execution. Let us go back to the table part is. So T1 analyze first, it will express the thing, write item and commit. So once it's commit, the database is updated to whatever the value of the X is plus 2,000. Then X, then 3,000 and this and so on. So it is these are the things that is written on this system. Now if you see this thing before commit, it is written as T1, right? X is 7,000 in the temperature or the temporary buffer, sorry. T1 updates 7,000 in the database, T2 reads, that is this thing. Okay. If a transaction T1 will execute transaction, T2 has to wait till T1 completes and its operation in the table program. And when the transaction T2 will execute transaction, T1 has to wait till the T2 completes on this thing. So the order can be T1 by T2 or it can be T2 by 1. This is a serial order of the execution. Okay. So T2 will start only when the T1 will finish and T2 will finish, then only T1 will start. That is the serial order of the execution. This is happening in part. With the help of the example, when the multiple transactions are trying to execute at the same time, a serial sequence order of the sequence database will be 100% consistent. So that is one of the most important. And this is our goal also. We need to get the table in the consistency. So our database has been the consistent. So the ideal solution is to get all the transactions to happening in the serial order. However, this approach of serialization can create some serious issues like waiting time we discussed. of the other transaction will increase, the response time of the other transaction is increased, resource utilization less, and in summary, system performance will be very poor. So we want serial, but we want in a different order. How is this possible? Now here the concept goes at the interleaving. So we're going to discuss that. To overcome these things, we add the concept of the concurrency. And we use the concurrent execution of the transaction. What it says is, in this approach, each transaction get a small time slot to complete this operation in a cyclic manner. Meaning the transaction operations are interleaved with respect to the time. What is with respect to the time? So if T1 starts here, T2 can also start. So it gets some time, it gets some time. After that, it gets some time, it gets some time. It is not that T1 has to finish first, then the T2 will start and so on. So we get the concurrent system. So where it is possible is interleaving at the operations. Now what are they? As there is only one CPU, only one program can be processed. To avoid excessive delays, concurrent execution system executes some operation from one transaction, then suspend the transaction, execute some operation from the next one, and so on. So let us T1 start, it does something, T2 start after this, then interleaving on the CPU of T1, then T2, then it's commit, after that, this commit. So this is the property of the interleaving. And with some rules and regulations, we are going to see that in the next videos, how we can ensure that while introducing interleaving properties, we want T1 and T2 or T2 in a T1. So in today's lecture, we have discussed about the concept of the asset properties, atomicity, consistency, isolation, durability, the concept of the concurrency, the concurrent execution, and the process of interleaving of the operation due to one CPU. In the upcoming lectures, we will discuss about how do we catch in the serial execution of the order, the important concept of the fixed serializability, serial view serializability. We have taken the notes from these other textbooks. Please like and share the video. Thank you.